Welcome everyone, my name is Amir Yekta and I am an ANSYS instructor from the Hyperlyceum group. In this video I am excited to introduce you to our ANSYS Mechanical Package, a comprehensive tool for learning finite element analysis. In this presentation, we'll be covering the key topics and contents of the package, and I'll be sharing my expertise as a seasoned instructor. Let's get it started. I'm graduated from Tehran University in Mechanical Engineering, and I hold Bachelor of Science and Master of Science in Mechanical Engineering. I completed my thesis on optimizing the mechanism and lifespan of a mechanical wood gripper. Throughout my career, I've worn two hats as a mechanical engineer. One as a FEA, means Finite Element Analysis Expert, and the other as a design engineer. Here, you'll find some examples of my previous projects which required me to utilize software tools like ANSYS Mechanical and SolidWorks to design and develop durable and efficient machines and mechanisms. Now that you have a better understanding of my background and experience, let's dive into the world of ANSYS. The term ANSYS is derived from Analysis Systems, a name that reflects its origins. Developed by ANSYS Inc., the first version of ANSYS were released in 1970. As a CAE means Computer Aided Engineering Software, ANSYS enables engineers to tackle complex and critical problems in various fields, including structural, dynamic, fluid mechanics, electrical, and magnetic analysis. Now the question is why we should use ANSYS Mechanical. The answer lies in the importance of designing and engineering critical components and mechanisms in every industry. By leveraging ANSYS simulation, you can significantly reduce costs and time spent on design and development while also optimizing factors such as safety and reliability. The ANSYS Mechanical Package curriculum covers a range of essential subjects. We began by introducing the various modulus and physical principles, followed by a thorough exploration of the tools used to create new geometries or modify existing ones. This is followed by a detailed examination of material definition, loads and boundary conditions, and the physics of contact and joints. The most complex and demanding topic, meshing, is also covered in depth. Finally, we guide students through the process of extracting and evaluating desired results in the results section. In our geometry section, we'll guide you through the process of designing or repairing complex geometries using a space claim, illustrating key concepts with real-world industrial examples. In the material definition module, you'll learn how to create new materials or modify existing ones, and we'll also provide a comprehensive overview of material theory. To make loads and boundary conditions more accessible, we'll use practical problems to illustrate these concepts. As example, we try to example each kind of loads and boundary condition that are provided in the software, and here we have tried to use a mechanical gripper as an example. Our comprehensive coverage of meshing includes all types of elements and methods, along with challenging examples to help you master different techniques. Here we have tried to provide some challenging and industrial examples. Finally, in the results section, we'll teach you how to extract and interpret the various results provided by the package and provide guidance on how to achieve reliable results and validate your findings. With this training, you will be well on your way to becoming a proficient FEA engineer. Thank you for placing your trust